Hey woodworkers, so I want to talk about sliding doors. So sliding doors present some options for us that might not exist with a hinge door, and there's some methods about designing and thinking about how to build these that we should discuss. So first of all, this is in the corner of a room, and we have furniture right in front of it, so a hinge door wouldn't really work, because if this would pivot out on the other side, then it would always interfere with the furniture. But this is an easier way to kind of get access to the things we need and without moving the furniture. So having access to sliding door first and foremost is kind of something to consider. If I have anything that's proud, so like a knob or a pull, it's going to interfere, so that as this one opens, wherever that is located, it's going to limit the amount of travel that we have here. So that's why I designed these to have this little finger hole for gaining access to it. But it moves pretty smoothly, which is important. Shouldn't have to fight this. And that all is predicated on the surface area that you have making contact with your guides or rails for this thing to option or operate, pardon me. So that's that. The other thing about these is going to be the removability of the door. And so if we think about assembling the carcass for what you're building first, and then installing the door after everything goes into this position, including finish, all that stuff has to get done, and then the doors go in and they're finished separately, and so on and so forth. It would be not inconceivable to build a carcass with the door in place, but then lacking the ability to remove that door becomes problematic for a lot of reasons. I'm always thinking about maintenance, things that may happen to this door that would require us to be able to remove the door to gain access to it. Then the other thing is, let's say the door gets damaged, something knocks into it, another piece of furniture, whatever. If the door is destroyed, worst case scenario, we don't have to pull out the carcass, we don't have to rebuild the carcass just because the door is damaged. So, alright, so that's the deal here. So, gaining access to the insides of the door for a sliding door, it's pretty straightforward. You have to raise the door up, it will then pivot out from the bottom, and then the whole thing will start to be able to be removed. So let me do that for you now. So raising this thing up, kind of tipping it down, pulling it out here. So talk a little bit about the methods for doing this, and there's a couple different ways to approach it. Let's see if I can show you a better example. Alright, so looking at the way that I designed this, you'll notice that there are a couple of rails or slides on the bottom, and I did this for a couple of reasons. I wanted to create the least amount of resistance possible, so when the door is in place and it's operating back and forth with this, I wanted to have it just bare on the very top edge of this little rail. And a lot of people make the sliding doors different. They basically, whatever the thickness of the door is, they'll cut out a groove. The door goes in there, top and bottom, and that's what allows this thing to slide back and forth. And I always feel like you see that most frequently, I think. And I always feel like that just becomes a dust catcher for anything, debris that goes into this environment is going to end up in that position. And the other thing long term is that after sliding this door back and forth for some period of time, I just feel like it's going to eventually abrade the finish away from your carcass, and I don't love the idea. The other thing with that is, if I were to put a groove here in this position with the thickness of the door, and then another groove behind it for the other door, I'm going to have some element of material between the two doors that will be strong enough to support these things and allow them to move. So that makes that larger than what I've got going on here. But it also creates a bigger gap between the rear door and then the front door. And so I feel like just putting a groove in, it's got a couple of issues. I prefer this method for just cutting out a groove here and then filling it back in with solid wood. And so that's what I did, top and bottom. And you'll notice these things. So putting it back in top first, kind of finding its way home. So you notice that now all the bearing surface is going to be on the bottom of the door, in the groove in the door. And I've made enough clearance on both sides so that it's not really rubbing front to back of this rail, just on the top. And I just think that's an easier way to get as little movement here or friction as possible to allow this to slide freely. And alright, so there's that. Over time, these things could start to wax is kind of an amazing thing. So over time, if this is cut tightly, and I would recommend overcutting this to allow it to run smoothly, but if there is any friction, just waxing the top edge of this should make this thing run pretty effortlessly, which is pretty great. And anyway, so those are conversations about the fit. So how this door was built is going to be something that I want to talk about here. I could do this out of a solid door, solid wood door. There we are. Yeah, better. But with a solid door, this thickness, this is 1/2 inch thick, this dimension, which is about 2 feet wide, I think a little bit over, I think maybe 26 inches. It's just not going to stay flat if it were solid wood. So I built this differently. You'll notice a section of wood here, and then end grain of this piece. So what I've done is in the center I've just used some plywood, and next to the plywood I've put solid wood edging here and on the other edge, and then I flattened those things out after they were glued on, and then I veneered front and back. And in doing this, it's the most stable way of creating a door, and you don't have to worry about cupping or twisting. Expansion, contraction is not really an issue with this style of door making, but this is an easy way to do it. And because this top edge is not going to be seen, top and bottom I should say, this is an easy way to kind of mask some of that construction. But alright, so that's what I've done there. And then yeah, so the last thing I want to point out here is the development of spaces for this to have clearance. So you'll notice a pretty sizable gap here on the top of the door, and that has to be there because when we raise this door up, there's got to be relief in that location. If this is joining to the bottom of this top rail, there's just not the clearance to get the bottom section out of the door. So pardon me, this is not touching at all in the operation of the door, and it's just really the front and back that are being led or guided with going back and forth. So alright, so when I raise this thing up, it does bottom out onto that groove in the door. So whatever gap is created here, that goes away, then I can pull this thing out. Another reason for making this groove slightly larger is to allow this to articulate or to pivot and then come back out. So those are the things to consider for making sliding doors. And lastly, this probably is self-explanatory to some degree, just making sure that it has a nice well-fitting edge top to bottom. And there's nothing wrong with having a little gap there, but if it were uneven, so wider here, smaller at the bottom, that would be a sign that we don't know what we're doing, and so I don't want to do that. Alright, hopefully that was helpful. The sliding doors, however you make them, solid wood or this veneered ply as I've done. Pardon me. Just consider the movement as far as operability, and then removal of the doors, which is going to be super important. And so you've done that, you should be just fine. Alright, thanks.